So I want to talk about the vDOM and how the virtual DOM actually works. So let me quickly I need also water. Can I have a water? I'm Stefan from Berlin. So you find me there on the internet. I do some community work in Berlin, teaching CSS, teaching Node when there's time, and I work for this company that's called Contentful. So in case you haven't heard of us, if you want to build your static site or your single page app, and you don't want to set up your own database and Apache server and deal with all these things, because all you want to do is consuming some JSON, you can give Contentful a try. Because this is what we do as a service. And who remembers what happened in 2013? I saw one hand. It wasn't a hand. 2013 was the year when React was released. And maybe I'm a little bit odd, but I remember exactly the moment and the day when I read the release post. So I was walking around the office in Berlin, and a few other front-end engineers were approaching me and were like, hey, have you seen Facebook release this thing? So I read it, and I have to say, I was not impressed. But to be fair, I didn't understand what that was in the time. And then a few years later, my perception of React changed to something like this. React is this super fast and revolutionary thing that uses the virtual DOM and JSX. So when you sum this up, and at the time what I thought about this is, it's just like magic, right? Facebook hired the smartest engineers out there. They locked themselves into the room, thought about algorithms and all these papers and stuff, and came up with virtual DOM. But I'm doing front-end engineering now for quite a while, and let me tell you one thing, and you may have noticed that already. There's never magic in code. Really, never. Sometimes you're working by yourself, and you hit a wall, though, and nothing makes sense, and you have a lot of bugs, and then it feels like magic. And what should you do then when you don't find a solution to a problem? You should take a break. Right, sleep over, drink a tea, meet some friends. And this is what I do when I'm sitting in my living room and I'm hitting a wall and I'm like, nothing makes sense and everything is broken. Then I call my friend Matthias. This is Matthias. He lives just around the corner. And then I was like, Matthias, want to join? And can you help me something? I've got some programming troubles. He's not a programmer, though. So there are two ways how I could get Matthias to my apartment. So first of all, there's the imperative way of getting him to my door. And this would be basically, Matthias, get out of your door, to the left, to the Frankfurter Allee, then again to the left, then to the right, Proskauer Straße, then to the Forkenbergplatz, which is a lovely park, and then my apartment is in number 22. So this is the imperative program paradigm that uses statements to describe control flow or program state. So Matthias is the program here, step by step by step. But then there's also the declarative way of saying, and this is for getting people to my door, is what we probably do every day now. It's like, come on, dude. I live there, you will make it, right? So the declarative programming approach expresses logic without describing the computation. So when we bring this back to programming, let's say we want to double values in an array. So in an imperative way, what we would do is we create a new array, we iterate over the old array, we double all the values, we push them in, and we return the new array. So declarative, we would just use array.map and say, I don't care, they are values, and I want to double them. And we can apply the same thing for interfaces. So when we look at this beautiful interface here, so it's a button with a little bit of gradients, I could add this functionality imperative. So I grab the button, I add an event listener, I toggle a class. Now I have to know how class list works. I check what is in there, and then I flip the text. Or I go the declarative approach, which is just like, hey, I want to deal with a button. And this is what should happen. So, but when you look around, usually what you find is that it is in something like this. And when I saw this for the first time, I was literally like, that's not JavaScript. What is this? Which brings me to the first topic, which is code transforms. So code transforms are a huge deal in our ecosystem today. And this is how it works. So you have a JavaScript file. This is parsed to something called an AST. Then there take some transformations place. And then we got a new JavaScript file. So let's have a look at some JavaScript code here. So this is 3 lines of JavaScript. And everybody uses emojis very, very often, right? And the party popper, so the tada emoji, is in my messages every day. So unfortunately, when I execute this now, JavaScript doesn't support colon, emoji colon. So what I did first is that I wrote myself my own BABEL transformation. So in case you don't know, BABEL is this huge thing which is massively included in our ecosystem. And how could we now make colon, tada, colon work in this ecosystem? So first we would have to parse it with a tool that is called Babylon. So to do this, we have to get the parse function from Babylon. Then we treat the code that we just saw as a string. And then we can parse this. The result is an AST. AST stands for abstract syntax tree. And this is one of these words. I'm just a front-end engineer, right? This sounds like science and computer stuff. So in computer science, an abstract syntax tree is a tree representation of the abstract syntactic structure of source code written in a programming language. So this is the AST for the source code that you just saw. So we've got a program node on top. Here we've got a variable declaration and an expression statement. So basically it's really just a big tree structure. So when we look at this first line here, this is a variable declaration. Here we've got a declarator, an identifier, a template literal, template element, an identifier, and a template element. If you want to understand how our ecosystem works today, there's this it's not beautiful, but it's a very useful tool, which is called AST Explorer. And you can just paste any JavaScript snippet in there, and it will tell you how BABEL works with this, how the structure of this source code is treated later on. And when you play with this tool, you will find out, man, ASTs are everywhere. So there are also different programming languages or something in there. So you see there that when you deal with GraphQL today, very buzzword, right, GraphQL, the schema resolution there also works with ASTs. Or Remark, a popular Remark parser, also works with ASTs. So ASTs are everywhere. Having a little bit of knowledge about these is very, very useful. If you want to learn more, in the context of GraphQL, my friend Stefan, so 2 Stefans, wrote about that and published that. So now we have an AST available. Now we have to transform that. And we can do that using BABEL Traverse. And how BABEL Traverse works, it uses something that is called the visitors pattern. So this is described by the famous book, Design Patterns, Elements of Reusable Object-Oriented Software. It's written by the Gang of 4. So when you study computer science, this book was recommended to you probably more than one time. So let's have a look at how the visitor pattern works. So this is, again, the AST we had. And now we're touching every node with an enter hook until we hit an end in the branch. And then we're going up and down again. This way, we can visit every node in our AST, right? This is all just objects that describe the source code that you write. And we can alter it, change it, modify it to our needs. So when we look at this, we have the AST and we parsed it. We can now use the traverse function. We can check for the template element, and then we can replace the tada with the party popper emoji. And then we have the last step, which is generate, and this is fairly straightforward. So we bring in BABEL generator, and then we can generate the code. So the result of this, so here we see the whole source code that I just mentioned. So when I execute this now, I just built myself the ecosystem that supports colon, tada, colon. And the cool thing is that, did you know that you can pipe into Node again? I just discovered that recently, which is actually really sweet. I think that's nice. So what you usually don't want to do is you want to write it by hand. What you do is you write yourself a BABEL plugin, right? The way how this works is that you export a function, And this then has several hooks. So here again, the visitors pattern, we want to touch every node. And then for template elements, we want to do this. This is a little bit more handy, and that's the common way to do this. If you want to learn more about how our ecosystem works, there's the BABEL handbook written by James Kyle. I would highly recommend having a look because this is how our JavaScript ecosystem works today. So why is this person talking about code transformation so much? 25% of the 40 minutes that I have. Well, here we go, right? It's not JavaScript. So when you write React or virtual DOM implementations, very often you use JSX. And JSX stands for JavaScript syntax extensions. So let's have a look at how this works. So here we have an app component that includes JSX. When this hits BABEL, we have a return statement here. We have a JSX element here, JSX opening element, JSX text, and JSX closing. And when we then transform that and put it into BABEL, this is the result. React create element. But virtual DOM is not tied to React. So the way how this works is that you can define something that is called JSX pragma. So I put it now here on top of as an inline comment, but usually this is in your BABEL config or something. And with this, you can control what this function call is. So heroify is nice, but usually people just go with H. In case you're writing React or Preact, have you ever wondered why you had to import something that you never used? The thing is that it is actually this code that is running later. JSX is just a transpilation to function calls. You don't have to write JSX, though, when you want to write virtual DOM. So, for example, we have some Vue people in there, or in the audience here, right? So this will be actually transpiled to function calls later. So if you want to see what Vue does under the hood, there's this tool that is called Vue Template Explorer. And the C, the _C function there, is the equivalent to React create element. And you also don't need a complex build setup. So for example, what I do in Contentful, we can extend our interface here. And the way it works is that I can upload HTML files that run then in the actual application. So what I always do is I inline Preact, because I don't need a build setup. I can use React without anything. Then I get the H and the render function. And this is all it needs for me to work with a virtual DOM implementation in a limited environment. Also, the React folks noticed, well, everybody thinks that you need BABEL Webpack to write React applications. This is not true. You can just use it and grab the functions that you need, because virtual DOM at the end are just function calls. And then just 2 weeks ago, or 1 week ago, this is written by Jason Miller. He's the creator of Preact. He released Hyperscript tag markup, which is tag template literals, then bind functions so that you can write something JSX-like for the development stage without using BABEL or something like that. I think that's really sweet. So, but why H, right? What is this H? H itself appeared first in this project that was called Hyperscript. This was one of the first approaches to writing declarative UI. So let's have a look how this started. So this is the H function, and it accepts a node name, attributes, and children. Then we create elements depending on the node name, right? This could be div, span, h1. Then we iterate over all the attributes. So this is an object. I want to make a little side note here. The for-in loop, right, is a little bit nasty at times because it messes with the prototype chain. It can be very slow in certain things. So when we write JavaScript today, object.keys is a little bit safer, or even object.entries, which means you get the key and the value. Writing a library, this talk was very, very nice. So if you want to see about the benefits of the new object functions, I highly recommend that one. But because this is how Hyperscript worked, I want to stay with this one. So we're iterating over all the attributes, and we're adding these to the element that we just created. So then it's time to iterate over the children. If it's a text node, we're creating a text node, and otherwise we append the children. So with this, when I have this little bit of code and this one function that I just had, I'm just creating DOM nodes right on the fly. And this is already declarative UI. But this is not what you usually want to do, so this is not a real application yet, so let's make it a little bit bigger. And let's add maybe a list and a class. So just to remember, this is how this would look like in JSX. And this is it with the H function calls. So now we have an app component. Now we need a render function, right? This app component returns DOM nodes. So we need the render function that keeps track of an application. So if it is rendered for the first time, it's adding it to the DOM. Otherwise, it's replacing it. And then it's keeping reference of that. Then we're defining some state. And let's say this is just attendees of this conference. And then we're rendering the whole thing. Ta-da! That already works. And this is 100 lines of JavaScript. And we can write things in a nicely declarative way. So let's add some functionality here. Let's say I define an interval that every second adds a random person to the state and is re-rendering the application. That also works, right? But when I now go to Chrome and enable this nice debugging thing that shows me what is re-rendered, we see that the browser is doing a lot of work here. And maybe we want to be a little bit smarter and save the browser some work. So when we look at the Preact documentation, what you will find there is that Jason made the statement, we want to render components and have them updated only when data changes. That's where the power of vDOM diffing shines. And when I heard this for the first time, I'm again like, what? Oh my God. So the vDOM is basically a lightweight representation of a structure of a DOM tree. And this structure can be realized by recursively comparing it against the current actually DOM tree. And when you go to GitHub and you look for virtual DOM implementation, this is what you find. So there's React, Preact, Inferno, SnapDOM. And I spend a lot of time with Preact. And a lot of time people approach me, Stefan, which one should I use? And I'm like, pfft. So what I want to tell you is, when you choose your library, you should consider a few things. So first of all, is the feature set included that you need? React versus Preact, React does way more. Maybe you just need a rendering layer, then Preact is probably fine. Do you need a rich ecosystem? Is the community friendly and people help each other? How's the documentation? 2 years ago, I switched to Vue just because the documentation was so kick-ass. I didn't hit a single roadblock because the docs were so good. Is it fast? Ready for my favorite icon? Is it stable? And how's the developer experience? Whatever library you pick, there are always trade-offs. And Henrik Röhrtek once said, you're shaping tomorrow's job market based on the technology choices you make today. So just using a library always has an impact. Technology choices affect your bottom line at the end. So we have H. So this is the function we just had. This rendered DOM nodes, right? So let's start making a virtual DOM implementation. And I'm shifting a lot of things around here. Ta-da! So now we have a virtual DOM factory. And all this does, it is mapping the stuff that comes in to objects that are going out. So when we now have our app, this was also returning DOM nodes just 5 minutes ago. What this now returns is a huge object describing our UI. This is how the virtual DOM works. It's just UI becomes data. But now we need a new function, let's call it render node, that accepts these nodes that are included in this huge tree. So we grab the node name, the attributes, and the children. Then we check if it's a text node by checking if the split function is available on this object. And now it's the same functionality again. So we create the element depending on the node name. We iterate over the attributes. And then we're going over the children and we're calling the same function recursively. So but now our app is broken, so we have to go back to our render function here initially. And the only thing we have to do is we call render node on this thing. And with this, we're back on track. Same thing, same result, looks completely the same. With the difference now that we have way more control because we have a data layer that describes our interface in a separated object. So let's talk about components. So this could be one component, but let's pretend that we want to write a class-based component. So this is how you usually do it. So you have a constructor. Inside of this constructor, you define your state. Then you have a render function that returns this object that defines the UI, right? So let's make this a little bit shorter. And now we have the render function here, and now it gets a little bit tricky. Because now we have different things that can be included in this tree. What we had before was that what was possible was only node name div span, so that node name always was a string. So let's cover this. But now we introduce classes, so we have to do another check here. Then the node name is of type function, because classes are functions in JavaScript at the end. I'm ignoring stateless components here. So if you're interested in how React figures out what to render, actually 2 days ago, Dan Abramov wrote this blog post. It was so good. It goes into JavaScript prototypes and how they figure out what to render when. Highly recommended. So I'm only describing the class components. So if the node name is of type functions, I know that this is a class component. So what do we have to do then? Well, node name now is a class, so I have to initialize it, call a new. And then I'm calling this new initialized object with the render function, and then pipe, which returns virtual DOM. And I'm piping this into render node, which then is the result is DOM nodes. And I'm storing the result in component.base. There's actually a lot of going on here, but the main important part is this. And this is so smart and beautiful. A component holds a DOM reference, which brings us to the re-rendering part of React, which is a powerful thing. So React re-renders when you call setState. So let's implement setState here. So I bring in this, the timer in the constructor, so same thing, right? State update every second, and it calls setState. And setState, all it does is has the state already, then I'm calling object.assign, and then I'm calling renderComponent. And I'm not using too many emojis in my slide, but this is programming art. Oh my god. So renderComponent is an independent function that accepts a component. All right, so far so good. So then we grab the rendered DOM nodes that are already in the interface, and then then you can re-render the new DOM nodes, right? Using component.render. You store it back inside of the component, and then you're replacing the old one with the new one. Oh my god. Components render autonomously. Once they're injected, all works by itself. There's no global render anymore. Once they're in, everything is cool. So when you have your application, let's say it's structured like that, and you call setState here. What happens is that it calls renderComponent, which calls render, and it goes down the tree. The rest stays untouched. So for my example, when setState is called in the list component, only the list is re-rendered. So and after implementing this is what we have. And only the list is re-rendered. All right, sweet. So we're getting somewhere. The cool thing here is, and I cannot say that enough, once it's in, setState does the job for you. But then there's a part of diffing, right? So we have renderComponent here, and what is available in this function? We've got DOM nodes here that are present in the DOM, and we've got component.render that just returns an object that is the virtual DOM. When you look at the structure of these two, well, they look quite similar, right? Node name, attributes, text nodes. So when we look what we do here is, this is a really expensive call. This is always replacing everything. So let's just start from scratch again. So this is the new vDOM. And what we could do is we could get the new vDOM application or the new vDOM representation, diff it against what we currently have, and return some DOM nodes to store that for the next one. So how could a diff look like? So here we have the same thing. We create new DOM nodes and replacing the old one, right? This is the case when we replace everything. But for my case, the only thing that I do is I'm adding entries to the list. So I could check if there's a new entry in the list, and instead of re-rendering everything, what I could do is I could add one child. Because I wrote the application, I know what is going on there. And the result is this. Sweet. Already had some diffing in place. So the idea of this is that you should only touch what's changed. So we have DOM nodes and virtual nodes, and the way you would structure your diffing algorithm is that you would go over node names. Is it the diff and now a span? Well, then we probably have to do a lot of work here. If it's the same element, maybe not. Are the attributes the same? And what about children? And then recursively diff your way out of that. So when we look at this, this would include a lot of logic. This would include the type comparison, the attribute comparison, and the children. And then you would optimize as much as you can out of that. 1.5 years ago, Jason Miller spoke about that at JSConf.eu, and so he showed a lot of nerdy and geeky details on how to optimize that. So, but the diffing is still an expensive part of vDOM implementations. So maybe we can save some work there. So let's say inside of set state, what we could do is we could keep track of the old state, which we just paste or which we just assign to the object itself. Which then means renderComponent could do a little programming trick. So we could flip the state around. So we're grabbing the current state, storing it in state and props, assigning the old or the previous state, and pretending, hey, component, please be what you were before. Yeah, like that. And what we now can do is we can implement shouldComponentUpdate, because we set the component back to what it was and calling it with the state that it actually is now. And this is how this works. Hey, do you have to diff all these things? This is how that works. This is where you will go, and please tell me if I should diff all the stuff. With this, you can save even more work. So I started implementing my own virtual DOM, right? 130 lines of code, 4 kilobytes. Worked for my example. When you look at preact, this is when you talk about preact, for example, you have to show the slide. This is preact, right? This is all. It's 8 kilobytes, not gzipped. It's optimized. It's covering all the edge cases. It's production ready. And I could have go on and build my own preact, but well, I don't have the time to maintain that. So the benefits of the virtual DOM are, first of all, you can write declarative UI. So you can define what you inspect and not worry about the DOM. I do think, though, that knowing how the DOM works is very important. So this is how this would work under the hood, but you can write it however you want, because virtual DOM implementations are just function calls. You can use smart and selective rendering. This is huge. The application or the virtual DOM implementation just keeps track of what should be updated. And you can limit DOM operations by a little bit of smart diffing here and there. And because you have the structure now of DOM and vDOM, you can even do fancy stuff like maybe batching all the writes, batching all the reads, and optimize and optimize and optimize. So I talked about the virtual DOM now. Is it the silver bullet? Who thinks that that's the end? No one? Who thinks new stuff is coming? Also no one. All right. There are also new approaches out there, which is like lit HTML and hyper HTML. And this is actually super cool. I don't know why this doesn't get a lot of traction these days. So I'm using lit HTML here, just because I think the API is a little bit nicer. So there you have an HTML and a render function. Well, this looks kind of similar, right? You can use tagged template literals, and then you have a render function. and then you append it to the document body. This looks a little bit like HTML that I showed you in the beginning. It works completely different though. So in case you don't know it, the way how this works is this is called a tagged template literal, and basically the HTML there is a function that is called, and when I lock the arguments here, you see that it has 2 arguments. It's an array with li elements and David Bowie. So and this is this one, and this is this one, and here we have a dynamic part that comes from the JavaScript land, which is David Bowie. So when I add another dynamic part, it goes onto the arguments list. So when we restructure everything now a little bit, we see that the first array is basically the static parts, and everything that follows are the dynamic parts. And this opens up a lot of more possibilities, right? Because the vDOM doesn't know what is static and what is dynamic. We have to figure out what changed automatically. With this, we know 100% what changed, and maybe this is the future and we can get a little bit better there. So this is a completely different approach. And it opens up a lot of new possibilities. So if you want to play around with this tag template literal approach, this is hyper-HTML. It's a few hundred lines of JavaScript, and it has a lot of inline comments, and it's surprising how quickly you can write a declarative framework that renders automatically. I think that's just super, super cool. I spent some time with that too. So to close the whole thing, in preparation of this talk, I read a lot of Preact code. And if you have read library code, it's not always the prettiest one. But you will learn a lot. But in the same time, I had this little person sitting on my shoulder that told me, you will never get it, Stefan. You will be on stage, and you will never get it. And I had a lot of sleepless nights because I was just freaking out. And Matthias was there a lot of times. I drank a lot of tea, sometimes a little of beer. When I'm stressed, I'm also going partying, which is a completely different story. But then at some point, it made sense, and my virtual DOM implementation worked. And I felt happy and I felt relieved. Very often, it just takes time to understand principles and concepts. And you have to learn and you have to be patient. Because at the end, all that matters is that we all know that there is no magic in code. And that is it. Thank you very much.